Okay, this is section 3.4. The learning target is we're going to use similar triangles to find missing measures. The success criteria is I can use angle measures to determine whether triangles are similar. I can use similar triangles to solve real-life problems. Similar figures are figures that have congruent corresponding angles. That just means that the angles that match up in each of the figures are the same, okay, same number of degrees. And then the side lengths are proportional. That means that you can set a ratio equal to another ratio. So in this case, the ratio of side length AB to DE, that ratio is the exact same ratio as AC to DF. And that's also the same ratio as BC to EF. Okay, so those ratios are the same. So once again, similar figures have congruent corresponding angles and proportional side lengths. So we're going to talk about angles of similar triangles right now. When two angles in one triangle are congruent to two angles in another triangle, the third angles are also congruent and the triangles are similar. The reason why that is the case is because all triangles' interior angles add up to 180 degrees. And then if you know two of the angles are going to be the same already, that third angle also has to be the same because the triangles are going to add up to 180 degrees. So there's only one possible number that would make that true. So anyway, in this case, we have 95 degrees for angle B, 95 degrees for angle E. We have angle A at 65 degrees, angle D at 65 degrees. So we know that they're congruent just with those two because the only possible number for the last two angles here of C and F has to be 20 because that is going to make those triangles add up to 180 degrees. Therefore, we know that the two triangles are similar. And this little squiggly thing right here, this tells us that the triangles are similar. So for this example, we would need to tell whether the triangles are similar and then explain. So if you remember, we need to make sure that we have two angles that are the same number of degrees in these triangles. Because if two are the same, then that third angle has to be the same as well. So anyway, in part A, I'll zoom in here a bit. I see that I have a 75 and a 75. Well, that's good. I see I have a 50 and a 50. So I have my two angles. Therefore, my third angle has to also be congruent. So X and Y and X, are also congruent. So yes, these are similar. And the reason is because we have two angles that are congruent in these triangles. For part B, we're going to look at this as well. Right away, I see that I have a right angle in each of them. So that is one angle that is congruent in the two triangles, but I need two pairs of angles that are congruent. So I see that I have a 42 right here, and I see that I have a 38 right here. Okay, well, these are not the same. So what I need to do is I need to solve for one of these variables, and if it is the same, so basically I can solve for x. If x is equal 38, then these triangles are going to be similar. But if x does not equal 38, then these triangles are not going to be similar because we won't have two pairs of corresponding angles that are congruent. So anyway, I'm going to solve for x. So I will do x plus 90 plus 42 equals 180. I'll combine my like terms, so I get x plus 132 equals 180. I'll subtract 132 on both sides. And I'll borrow this 7, get an 8, and a 4. So I get x is equal to 48. Well, 48 is not the same as 38. I should put the degree symbol here. But either way, I know that these are not going to be similar because these angles are different. I could solve for y, but I don't need to because I already know that we only have one pair of corresponding angles that are going to be congruent. So I know that these are not similar. And now we're done. For this example, we want to determine whether triangle JKL and triangle JMN are similar. And we have to explain. So JKL is one of our triangles, so this smaller triangle, and then we see JMN as our other triangle. So remember, we need two pairs of congruent angles in order to determine whether or not they're similar. Okay, because once again, if we have our two pairs of angles, then we know that last pair of angles also has to be congruent. Anyway, I see that I have angle J in both of these triangles right here. Okay, so angle J is going to be the same as angle J. So I know I already have one angle. Okay, so angle J is going to be congruent to angle J. And then if you see, I have parallel line segments right here. Okay, so what that means I can do is I can tell that angle K right here, angle JKL I should say, and angle JMN, so these two, I can tell that these two, and I'll put two rings right here, these are going to be corresponding because I have parallel lines, and if you look at it, they're in the same section of the intersection. If we treat this line segment JM as a transversal, M and K, these two angles right here, are in the same section. Therefore, I know that they're going to be congruent. Now that I have two pairs of congruent angles, J and J, and then K and M, I know that my third pair are also going to be congruent. Now, you could have figured that out. Angle JLK and angle JNM are going to be congruent as well because of these are corresponding angles as well. So anyway, we know that these are similar because we've proved that there's at least two pairs of corresponding angles, which means the third pair is going to be corresponding. So they are similar. And now we're done. You plan to cross a river and want to know how far it is to the other side. You take measurements on your side of the river and make the drawing shown. What is the distance x across the river? I'm going to zoom in on the figure here. So I see that this x is the distance I'm trying to find. I have a length of 40 feet right here. I have a length of 50 feet right here from B to C, and then I have a length of 60 feet from A to B. Okay, well, the way I can solve this is prove that these two triangles are similar and then use the fact that similar figures have proportional side lengths in order to find my missing value. Okay, so I see that I have a right angle right here. Okay, so this is a right angle and this is a right angle. So I have one pair of congruent angles, but remember I need two pairs in order to prove that my triangles are similar. If you look at this angle right here and this angle right here, these are vertical angles, and I know vertical angles are congruent. So this angle and this angle are congruent. So I've just proven that ABC and DEC are going to be similar triangles. And because I know that they're similar now, I can use the fact that similar triangles have proportional side lengths. Okay, so that means I can write a proportion. So remember, a proportion is just when two ratios are equal. And the most common way that we see ratios when we're dealing with this is in fraction form. Okay, so I just wrote a fraction bar equals another fraction bar. Okay, well, I need to figure out what x is. So I'm going to use this 60 feet. If you see, this 60 feet is across from the angle that is vertical, and the x is across from the angle that is vertical. So what I'm going to do is I'm going to have 60 is to x, aka 60 over x is the same as, and then this B to C is the right angle to the vertical angle, and then this E to C is the right angle of this triangle to the vertical angle. So know that these are also proportional. Okay, so I started out with 60 is to x. So since I started with this triangle, I'm going to continue to start the second fraction with this triangle. So that's going to be the same as 50 is to 40. So this is going to be 50 over 40. Okay. Now, this is not the only way that you could have set this proportion up. You could have taken the reciprocal of both of these sides. It could have been x over 60 equals 40 over 50. You also could have done 60 and x on the top, and then 50 and 40 on the bottom. So you could have done it like something like this. But I'm just going to use the proportion that we set up first. So I'm going to erase this one. And now, if you remember how to solve a proportion, there's lots of ways to do that. The most common way that I see is to cross multiply. But before we cross multiply, I see that I can simplify this fraction, 50 over 40. I'm just going to cross out a 0 and rewrite this as 60 over x equals 5 over 4. Okay. And the reason I did this is because now I actually don't have to cross multiply. I could. It'll work every time if you cross multiply properly. But I see that I just simplified this, and I see that I have a 60 and a 5. Okay. Well, to get from 60 to 5, I can just divide by 12. To get from 5 to 60, I just multiply by 12. So if I multiply by 12 on the top of this fraction, to get from 4 to x, I can also multiply by 12. I can do 4 times 12, which I know is 48. So x is going to equal 48. Okay, and I will show you how to do that using cross multiplication. So if I didn't even simplify the fraction, I can cross multiply and get 50x. I'll draw a line here to show that I'm doing it differently. 50x equals, and then 60 times 40 is going to be 24,000. Okay, well, I can divide 50 on both sides. 0 crosses off, and then I get 240 divided by 5. If you don't know what that is, we can do it out. I'll do it out using long division. 5 goes into 24 4 times, and then 5 goes into 40 8 times, so we still get 48. And then I want to answer the problem with a proper unit. So what is the distance x across the river? Well, it's in feet here, so I'm going to say x is 48 feet. This missing distance is 48 feet across the river, and now we're done.